Hello, everybody. My name's Eric Womack. I'm a professor in plant and soil sciences and the Deputy Dean and Associate Dean of Research and Grad Programs in the College of Agriculture and Natural Resources. So I have a great deal of interest in graduate programs and in research at the university broadly. And certainly the currency of research is scientific publications. We all know that. And so I had the fortune several years ago of being invited to be an editor of Applied and Environmental Microbiology. And Harold called me up and did this amazing sales job on taking on what is actually a pretty intense job of being an editor of a scientific journal. So what does that mean? Harold will probably touch on this, but the editor is the one who takes the paper, decides, do we really want to review this or not, and may editorially reject it, or send it out for peer review and usher the manuscript through the whole peer review process. I put it together with Harold because he guesstimates around 30 manuscripts a month for about the last 22 years, and we came up with something on the order of pushing 8,000 manuscripts that Harold has been involved in the publication of. So it's really the foundation of our enterprise, the production of peer-reviewed manuscripts. And Harold taught me an enormous amount about how to evaluate a manuscript, evaluate the science, and the reporting of that science. And it's really the bedrock of what we do. We tend to groan about it, it's like democracy. It's the worst form of government except for all the others. Peer review is the worst form of evaluating these except for all of the others, right? So we all groan about peer review. We spend a lot of time doing it, but it really is ultimately the best system for ensuring that what we say and what we publish has met scientific rigor. So we're fortunate to have Harold speak to us today. He is actually a native of the area, grew up in Bethlehem, Pennsylvania, moved out to the Midwest, did his bachelor's work at the University of Kansas, and postdoc at Case Western University, and then was a professor for 10 years at Ole Miss in Jackson, Mississippi, is that where? Oxford, Mississippi, and then got a job offer he couldn't refuse at the University of Bayreuth, a chair position at a German university, and has been there for the last 30 years as the chair of ecological microbiology at the University of Bayreuth. He has, I mentioned the 8,000 papers, he worked as 14 years as an editor at Applied Environmental Microbiology before becoming the editor-in-chief, and has been the editor-in-chief of this publication for the last 8 years. AEM at one time was the publication in environmental microbiology, covering many, many areas from food science to the global ocean to deep in soils and mines and you name it, everywhere microbes exist, which is everywhere. And so it's my pleasure to introduce Harold. Thank you.
So, thank you, Eric. Yes, I had the good fortune of twisting Eric's arm a few years ago to become an editor for Applied and Environmental Microbiology. And he suggested that when I came here to give a scientific talk tomorrow, that I should also perhaps convey a little bit of what I have learned in my 40-year career as a professor, what is involved in the art of publishing some scientific research. And the art of scientific publication is exactly that. It's an art. And for the most part, it's a learned art. So I think most of you are young. Everybody looks younger than I am, even Eric. But who's a student? Good, most of you are students. Any faculty? A couple of faculty, and young faculty. So the talk I will give today, I've tried to put something together that would perhaps work for this audience. So I'm a microbiologist, but I work in interdisciplinary topics, and so I've touched on plants and soils and animals and different types of things like that. And so I have an appreciation for the broader sciences. And so who's interested in plants? Who's interested in microbes? Who's interested in physics? Chemistry. Beautiful. Mathematics. So we have a very diverse group. Now when I say something, you have to realize that if you're a chemist, I'm a microbiologist. So some of the things I might say are a little bit skewed, but I think that in general, the things I might be able to convey are sort of universal and cut across the scientific disciplines. Okay, so it's a very broad-based group here, and I think the first question we would want to ask is turn on the pointer and then skip. And so why are you here? What do you expect to learn? What do you want to know? So I would like to know, why are you here?
To not get rejected when I publish.
Aha! And why are you here?
To get how to publish paper.
Aha, good. So how to publish and how not to get rejected. There must be some common ground there, isn't there? That's it. Well, you're laughing. Why are you here?
I work for Eric.
Aha. Okay, so we're here for maybe different reasons, but in the end, what we're all trying to do is figure out how can we publish something. So let me tell you now a little bit of what I have learned and what I have tried to teach to my students over the last long time. Okay. Well, I am the editor-in-chief of this journal. 210 years ago, this university got started in 1743. Yeah? So 210 years after that, this journal was created, if you will, Applied and Environmental Microbiology. We won't spend any time in this journal, but it's one of a jillion scientific journals. And if you're interested in publishing, that's where we do it. We can change the name, but that's where we do it. And all journals look the same. They're not round. They have a square format. I don't know why. Why aren't journals round? Why don't we invent a round journal?
Then we need round bookshelves.
Yeah. So what is this journal about? Well, it's a big, big journal. It's not small. It's very, very large. And so if you work with this journal, you actually learn a lot because of its size, if for nothing else. So there are 25 editors in 12 countries. There are over 400 editorial board members that are in 32 countries. This is a big international journal, very broad-based, and a lot of people out there working towards the same goal, publishing good science. The editors make the decision. As Eric said, the editorial board members recommend to the editor. So this is the logistics of most journals. What is the value to the society of a particular journal? Well, I could talk about other journals, but let's focus on AEM as just something that's representative. So it's a very broad-based journals, and many journals in all of the disciplines some of them are very, very broad-based. Some of them have a very narrow focus. AEM has a very broad base, so we publish things on plants, animals, soils, the atmosphere, anything, basically. Protein, anything. We'll publish almost anything in the health sciences and in the non-health sciences. Almost anything you get published in AEM. It is the #1 cited journal in the field of microbiology and the #1 cited journal in biotechnology. So what's always good in a journal is if you publish there, you want to know that your stuff is going to be seen. So obviously, if it's so well cited, your work, if you publish here, will be seen. And this is sort of something to think about when you publish something. Well, will people see my work? So if you publish in AEM as one example of a journal where you will be seen, in other words, you can't hide if you publish in AEM. Well, how big is this journal in terms of submissions? We get about 3,000 per year. This is actually one of the largest journals that I know of on the planet, not only in microbiology, but in all disciplines. So it's a very large journal in terms of submissions. Where do those submissions come from? I see a diversity of people here, okay? Almost 40% of the submissions come from Asia. And this is sort of a general trend in the sciences. Most submissions don't come from the United States, where we are right now. So this is North America and includes Canada, for example. And so North America at the end of the 2 world wars was way up here. That has changed. Everybody's healthy again, and everybody can do something. And so Europe is number 2. North America is now in the 3rd position. This will not change. The margin between these will probably continue to grow a little bit until Asia plateaus out, and probably it will go to about 50%. Well, the bad news is not just for this journal, but for most journals where you would probably want to publish. Most manuscripts are rejected. This, of course, is not what you want to know. When you're a student, you rightfully assume that collecting the data, making the observations is the harder work. That's not true. The hardest job is to publish those observations. And why is it the hardest? It's because even though you have successfully generated information, the likelihood of having your manuscript rejected is high. 70%, 75, 80, 85% of manuscripts are rejected by a great number of journals. So this is probably sort of why you're here. Now the faculty that are here, I will now start telling you a few things that you might want to know if you haven't learned them. The faculty who are here know these things already. So they will be able to sort of see, aha, you know these things. A lot of things are common sense, which you will figure out, I think, by the time I am done. How many of you have not submitted a manuscript? How many of you have had a manuscript rejected? Good. So we have a common ground here. Okay. So what's the solution? What's the solution for avoiding the rejection of a manuscript? Don't submit. So the best success rate is to never try. You can always say at the end of 40 years, I never failed. So unfortunately, you will also have no career. So let's try to think now about how do we write a manuscript and what are the things that matter? And they're all extremely basic. This is not space age stuff. This is very, very basic. But you're not born with this information. You have to learn it. And the faster you learn, the better off you are. So things that matter. This is just too bright up here. Is it possible to kill the front so that these panels are, that's better. Isn't that better? Good. You don't have to see me, you have to see this. So things that matter. One of the most important things that matter are potential violations of publication ethics. Before you even start to do something, if you cross this line, it can be a fatal event. Many, many manuscripts are rejected because of this problem. What are these potential pitfalls then? Well, 2 things at the very start. This will be full. By the time I am done with this topic, this will be full. Prior publication, duplication of substance. These are very, very close. Very, very close. Prior publications mean that you attempt to publish exactly the same information. In other words, double publication. Not a new experiment, but double publication. Of course, we all know that that's wrong. People try to do it. Okay? Duplicate substance. This means that you do the experiments exactly the same, again, generate a new data set, same conclusions, and you try to publish it again. That's called duplication of substance. That is also unethical. Okay? Don't do it. And if you do this, and it's discovered, your reputation goes way down. And coming back up out of that hole is not easy. So this is a fatal error, in some cases, for an entire career. Don't do this ever, ever. Duplicate submission. This is a little more subtle. This is like rolling the dice a few times at the same time on the same craps table. You're only allowed on the craps table, in Vegas at least, to roll 1 set of dice. But just imagine rolling 3 sets of dice at the same time, hoping to come up with, instead of snake eyes, a 7. That is illegal. You must submit 1 manuscript to 1 journal at a time, wait until you get the result back, and then submit it to another one. Do not roll the dice more than once with any one manuscript. The cover letter is a very fatal part of that. If you submit to a journal and it's rejected, and you forget to change the title of the journal to which you're submitting the manuscript the second time, and you tell them in your cover letter that it has not submitted to another journal, but we hope to publish it in then journal X, and it's not the right journal, your manuscript is either editorially rejected, because it's proof of evidence, if you will, that it's a double publication or a double submission, or the system is stopped. And this will take perhaps a week or two to resolve that, and it may be allowed to roll forward or not. So the cover letter sounds very trivial. It's not. Cover letter's important. An undisclosed resubmission. What is that? Well, your manuscript gets rejected. You want to submit it again to the same journal, but you don't confess to the journal that it was rejected earlier. That manuscript will be editorially rejected immediately. When that's discovered, it never sees the light of day. It is just rejected. Okay? So don't resubmit and not declare that. It's a simple error. And it's avoidable because every journal asks you, have you submitted this to us before? And when you say no, but you have, the journal will know because they scan all this stuff. So, this, of course, is very simple to understand. Your data, you should not manipulate. Okay? Images, data, raw data, don't lie, if you will, with the manipulation of your data sets. And this is easy to do now with cyber tools, especially for images, gels, or whatever. So to manipulate the data is unethical. If you do this now with the cyber tools we have in the publishing industry, this will be discovered. So don't think you can get away with this. We could 40 years ago, quite easy, but not anymore. So plagiarism, this is of course one of the bigger ones, and it's actually percentually the most common problem in terms of violating publication ethics. Plagiarism, text recycling, using something 2 times to plagiarize. And so, for example, if you reuse text, this might be easy in the introduction and in the discussion because somebody else is a brilliant writer and you just want to use those sentences. And it makes your introduction or your discussion much better. And so you do that. It's a mistake. You want to get your manuscript rejected? Do it. Methods. This is interesting. Most journals allow the methods section of a journal to be plagiarized because there's only so many ways you can describe a method efficiently. And so this is where the publishing industry draws a line and say, you can publish anything a jillion times in the methods section, but not here and not here, and never in the results. So the data has to be unique, and the text used to describe the results have to be unique. And in the end, you have to understand now that your manuscripts are going to be scanned for information that is out there in cyberspace, not only in journals, but on the web and any place that's publicly available. And so AEM utilizes a search engine called CrossCheck, and we can scan any manuscript for replication of information, of text, and we can set that search window, that scanner, for any length of sequences of words that we want. We can set the window to 3, to 4, to 5, to 6, to 7. And once you get up to 6 or 7 words in a string, it's very dangerous because the likelihood that you're plagiarizing is not imaginary but real. 2 or 3 or 4 or 5, that's boring. But once you get up to basically a full sentence with just 1 or 2 words that have been changed, that's plagiarism. And these scanners, these cyber scanners, will detect that. So be very careful. Remember now that we can find you if you are trying to do this. Okay? Do not recycle text. Bad nose. And for the professors who are here, be very careful. Who writes the first draft? The students. At least they should. They need to practice. If your students give you a manuscript that reads beautifully, you probably have a problem on your hands. So the professor should be very careful here. And in fact, when we reject a lot of manuscripts because of plagiarism. Who gets the call? Not the first author, not the student. It's the corresponding author, the professor. And then the professor comes immediately. I never knew. I never knew. We never, of course, would have done that if I could have known. So the professors, of course, are the ones to blame because they're in charge of everything. But the students will generate the problem at the beginning, sort of unknowingly, hopingly, well, knowingly, I think, but hoping that nobody discovers that they have done this. So people who get beautiful, professors who get, so principal investigators, corresponding authors, the bosses, when you get a brilliant manuscript as a draft from a student, don't trust it. It could be brilliant, but you can get these scanners for free on the internet, so scan them. Things that matter. So we've talked about publication ethics, and we've also mentioned something about the cover letter. Let's now go to the instructions to author. Every journal is different. They have their own instructions to author. Read them, even if they're 20 pages long. They're designed to help you. How? To be successful with that journal. Not for the next one, but for that journal. Every journal has its own little perks and twerks. And so if you are interested in submitting to a journal, read the instructions to authors. And one of the things that you will discover is that there are scope statements. The journal will tell you if they want your information or not. Don't submit it to a journal that doesn't want it. So read the instructions to author and pay attention to the scope statements. This usually occurs at the very beginning of the instructions. And then also in the instructions is the formatting that is expected for that journal. Now, why do we care about the format? Well, if the format is not according to the journal's format to which you submit the manuscript, the first thought of the reviewer is going to be negative for you. They're going to think, oh, you haven't formatted it for this journal. You submitted it first to a different journal and it was rejected. And now you submit it to my journal. I'm going to look at it very carefully. There must be something wrong. Okay? So this formatting is very serious. It's a polishing, it sort of is superficial, the science doesn't change, but the format matters at the level of the reviewer. Not at the level of the science, but at the level of the reviewer. And if you give them a false impression of previous rejection, you do yourself a disservice. So the title of the manuscript is, in my opinion, the most important. It's the first thing anybody sees. Bad title, no interest. Interesting title, oh, let's look and see what else is coming. So the title matters. Well, there's something that I try to let people know. What you did is actually boring. I'm sorry. What you have done is not, everybody does something. Everybody does something. It's not interesting. What did you see? That's interesting. That's not what you did. That's the novel observation. And the title should bring the novel observation out somehow. And that's not easy sometimes. So what do we have to try to focus in on with the, we need to bring the news forward. That's what's important. And methods. I don't know why, but in biology at least, a lot of the microbiological sciences, we spend a lot of time in titles telling people, we use this method. Aren't we cool? Everybody uses the same methods. It's not the science. It's the method. And so the more methodological information you put into the title, the less likely it is that the reader can see something novel in it. And the reader needs to see the novel science, not the method that everybody uses. Okay? So, and lastly, if you look at the impact, the citability, if you will, of a manuscript, you'll find out there are programs that have figured this out. Short titles get cited more often. So if you have a long title, the chances of you getting cited, even if the paper is accepted, is less. So short titles matter. I know that more is always better, but not always. So here is an example of a bad title. And this is microbiology, so I'll apologize to the physicists, but here's a bad title. Molecular and chemical analyses of cellulose-degrading microbial communities in oil-contaminated soil from Kansas City. What is that? Well, you know what the person did and how they did it. And where they did it also. But what's the point? You'll never get it from the title. Here's a good title. novel cellulose-degrading soil bacteria are induced by oil. Now, if you're a microbiologist, you'll realize that that's really odd. How can oil induce a cellulose-degrading microorganism? That must be some very interesting community dynamics at the level of the function of some. So that's intriguing. Let's look and see what's in the abstract. So try to make a short title that brings some novel observation forward, which is then the reason why you would look at the abstract. The abstract is not complicated. You have to the problem with the abstract is that it's short. But you need to state at the very beginning in 1 or 2 sentences, has to be very short, but to the point. You have to explain why it's worth reading the middle of the abstract. Don't lose them at the first sentence. So you really need to get them with the first sentence. You have to explain something of importance, a general something that maybe several people would take. And then you have to explain as quickly as possible, at least 1 or 2 sentences, how you actually did this, how you made these observations, and then tell them what these observations were and what novel conclusion you have reached. Nobody else has made this conclusion before. That should be the last sentence of the abstract. Okay? The introduction. I always think this is the easiest thing to write for most manuscripts, but my students tell me that it's the most difficult. Well, why is it difficult for students? It's because you just want to say too much. And so the introduction needs to be very simple. It needs to be a linear series of thoughts. The thoughts need to be connected. Anybody can just regurgitate information. Well, what's the chain of thoughts that needs to be linear, and the shorter the better? I tell my students I want 2 pages of double-spaced text. Any more, I won't read any farther in the manuscript. No, 2 pages double-spaced. If you can't do that, I won't read it. And actually, the introduction might get a little bit longer then in the process of writing the manuscript. But I force them to tighten their focus on the introduction to make sure that in the end, the reader comes as quickly as possible to what we're trying to do here. And in the end, you need to formulate a good hypothesis. Some studies maybe there isn't a hypothesis that's good behind it, and maybe you could end with some very novel objectives. Okay? But something you should not end the introduction with is a second abstract. Many publications, and I know you may not realize this because you don't really care, but trust me, when your introduction ends with a second abstract, it reads just like the abstract of the paper, okay, with a few different changes, but you tell them about the methods, and you tell them about the objectives, and you tell them about the results, and you tell them about the conclusions. That's the abstract. That's not tasty information for wanting them to actually go to the results and look and see, well, what did they do? Here's the hypothesis. How did they test that? Here's the objective. What did they see? Don't tell them in the introduction what you saw. They're supposed to want to read more. Okay. And then the results. Well, this is what the results are. Basically, they are pearls. You go out there and you try to find an oyster and you open it up. Sometimes you find a pearl. Well, the pearl is actually not enough. You have to get rid of the sand and you need to polish that pearl. So a lot of the oysters that you look into have things that you basically need to throw away, as painful as that is. But once in a while you see these wonderful pearls, and these become the main findings of your work, and they need to be polished and cleaned. Now, when you're trying to sell your results, of course you have graphics that are involved in selling this. A table of numbers, that's sort of easy to conceive. You have numbers, and that's okay. You can't really make any real mistakes, hopefully, with your numbers. But to convey graphic information, there's some old-fashioned common sense rules. And old common sense tells us that this is actually the wrong 4 symbols to utilize to somehow convey information in some sort of a graphic form, in a figure. Why is that? It's because there's minimal contrast. Now, I know I've made them big enough. You can see the contrast. But the contrast is actually very small if you make them small dots in a figure. These are the 4 symbols that have the maximum contrast. There are no other 4. So if you have a graphic situation where you need 4 symbols, those are the 4. If you change that to a triangle, that is not as distinguishable as a square from a circle. Very old-fashioned stuff. Nobody cares anymore, but if you want to sell your data, make sure that the reader, the reviewer, can see it and digest it quickly, not painfully. Well, of course, now, 40 years later, that's what I learned. So now we have colors. Oh, colors, this wonderful PowerPoint. I can do everything. These colors belong in the bathroom. Okay? These are pastels. Pastels are good in the bathroom. I don't know why, tiles or towels and tiles. So pastels are just wonderful, but not for scientific publishing. Maximum contrast. If you want the reader to see it, give them a chance. So just like these symbols that are just black and white have maximum visual contrast, penetrating colors also have maximum contrast. And you help yourself because you sell your work easier. So this brings us down to the discussion. Well, what is the discussion? Well, what's very good to remember is that the reader has just read all of your stuff. Don't start the discussion with your own stuff. Go back to the world and cite the literature again. Lead in with some sort of a historical perspective, something that you haven't perhaps said in the introduction either, something new, but something that requires literature rather than your results. That's always a great lead-in paragraph for a discussion. Now, the rest of the discussion is straightforward, so to speak, because what you're trying to do then is take the main observations and putting them in context with the literature. And so this is where you're going to be citing the literature heavily in the discussion. And then you want to, somewhere in the discussion, I tend to think that the end is sort of a nice place to put this. You have to confess your sins. You have to say that, yes, okay, we know we're great, we know we're brilliant, but you have to acknowledge the limitations of your findings. You push the ball of science forward just a little bit, but then you hit something. And so it's good to remind the reader that there are limitations here. We don't know everything. We haven't solved every problem. And basically acknowledge that. And then the best way, in my opinion, to end the discussion is with a novel conclusion. Perhaps springboarding onto then, what does this novel conclusion mean for the next push? What might we want to now look at in the future? And then last on this, things that matter are first-time claims. Of course, everybody wants to say, this is the first time that anybody has ever done this. Okay? It's true that most of us do something for the first time. But if something is not new, it should not be published. So if you are submitting a manuscript, we know it's the first time. We just know it. Or else you wouldn't be doing this. Okay? Why would you be doing something for the second time? You wouldn't. So we don't find this statement in the literature. This is the second time. We don't say those things. And so when you submit your manuscript, you don't have to try to convince people that you're the first to do this. We know that. By virtue of the submission, we know that. So try to avoid first-time claims. And one of the main reasons is that you could embarrassingly be wrong. And this happens. And when that happens, you can get sued, by the way. And I have dealt with these types of cases. You get sued. Why? Because behind a first-time claim could be in industry money. And they're just waiting to be able to make money in other ways sometimes. Be very careful when you claim to be the first. You may trip the wrong trigger. And the main thing is it's totally unnecessary because your science will speak loudly for itself. Okay? Can you see the screen? Or you could sit there. I should have done this earlier. But we're over now, so you can. Okay. So what are manuscripts? Well, I try to tell my students at least that it's relatively simple if you boil it down. The introduction is like a thread. And the results are basically the pearls. And the goal of the discussion is to thread the pearls to thread the pearls, basically. And so when you get to this, very simple-minded, of course. It's sort of embarrassingly simple-minded, but that's basically what it is. you have an introduction with the thread, and you're going to put something onto the thread, something that's new, pearls, and you get a necklace. And then in the end, if you're lucky with your necklace, you get a really novel conclusion, a take-home message. And this is basically what a manuscript that's successful looks like if you were to make a Picasso out of it, an abstraction. So necklaces are what we're trying to sell here. Now, if you're lucky, the manuscript will not be rejected and it comes back for modification. What do I do? Well, you have to address all of the concerns of the reviewers, and you have to then precisely, concisely describe how you have dealt with those problems in the manuscript, and then in the end also be thankful. Make sure that you are not aggressive. If it's sent back for modification, you're almost to acceptance. And authors who become aggressive at this stage can get their manuscripts rejected very easily. Sometimes these manuscripts go back to the reviewers. They come back modified, they go back to the reviewer, and the reviewer reads these very aggressive comments and then it gets rejected. So be very careful, be thankful, appreciative, try to realize that there are a lot of people out there and they see science from different viewpoints, and they express those viewpoints in the review. So what have we seen? A lot of things that matter. So writing a manuscript and needing it published is not really so straightforward and easy. It's a fairly drawn-out affair. But in the end, common sense matters. Some of you have a lot of common sense, and if you use that common sense, then you minimize the pitfalls along the way. Those of you who don't have common sense, try to learn some common sense and make sure that you somehow avoid as many pitfalls as possible. Now there's the other side of the equation. I'm the author in this talk, basically trying to write a manuscript and publish it. But who looks at that manuscript? Reviewers and editors. So in your careers, if you stay in academia, you might ask the question, how do I jump over the wall and become a reviewer? How do I become an editorial board member? How do I become an editor? How do I become a chief editor? So some things are not straightforward. Getting to this point is not too difficult. Getting to this point is more challenging. And then the deeper you go, the more likely it is that there's a lot of factors that play into the final moment when that happens to you in your career. In any case, publication is a fun thing also. It's challenging, and it's a fun thing, and at the end of the day, like Eric said, it's why we're scientists. We try to produce information for society. So I will close with this and wish all of you luck polishing and finding, of course, your pearls, and in the end, success in publishing them. Thank you for your attention. And maybe the microphone so that people can hear. Yeah.
So one thing I was curious about was your thoughts about replicate studies. There's a lot of push for many scientific venues to, or a lot of scientific experiments to actually have replication done to ensure that the data we're finding is, you know.
So confirmatory information.
Yeah, but
So,
like as you said, if it's not novel, if it's not a first-time situation, or it's not being reported first time, it may not necessarily be published.
So confirmatory information is not the same as duplication of substance. And certainly it's not duplicate publication. Now, if somebody discovers something with that particular system and does those experiments, and then somebody else comes along and does exactly those same experiments and wants to publish exactly that same data set, in microbiology at least, that won't happen. That's not really confirmatory. Well, you could, it depends on what you mean by confirmatory. But this, in the strictest sense, duplication of substance and duplicate publication is a no-go. So confirmatory information, that's very important. And in many, many papers, what you read, at least in microbiology and biological sciences at least, is that within a new data set, the first half of the story is confirmatory, not duplicate. Okay, not a duplicate, but confirmatory within the constructs of a different system that we looked at. And we saw very similar observations with that system that had been published in other systems, meaning that there's some sort of a universality. That's English. I can't do English very good anymore. 30 years in Germany, you lose certain things. But then the second half of that publication goes forward and addresses something new and novel. So a part of the data set is confirmatory within the constructs of a new system, unanalyzed at that point, piggybacked onto, if you will, novel information. But yes, confirmatory information is important in science. But the discovery of the US by Columbus probably wasn't the first either. Sorry.
I will continue the theme of replication. I am from psychology, and we are having this replication crisis right now.
Ah, interesting.
And people in the area are highly inspired to do replications, but editors are not very urged to publish them because it's not novel, right?
Yeah.
Especially if it's not some scandalous thing.
Yeah.
So how do you? How can one, I don't know, like write something in cover letter or write the submission in the manner that will convince editors that it's actually important thing?
Yeah, I don't work in that particular, in psychology or psychiatry, I mean psychology. I don't work in that type of scientific field. So maybe in certain scientific disciplines, there is a need for true replication of something to find out, is it real or not? And why not? If that field requires that replication, then let the science decide. And of course, the editor then also has to be sort of agreeable. And this is then perhaps based on the quality of the data set. So Eric would agree with this. So for example, we have in biology, like in all scientific disciplines, we have a toolbox. The toolbox in biology has changed in the last 20 years. Well, it changes every 10 to 20 years anyway. So the questions we could ask 50 years ago actually are the same questions we're asking today. But we have tools that give us a huge data set instead of an extremely biased data set. So we are allowed in biology to ask basically old questions with better tools. But what you get are totally different answers. And so the results are novel because the tools allow us to actually bore much more precisely and deeper into the heart of that problem. And they couldn't do this decades ago. Now in psychology, I don't know. Is this also true? You have learned enough to where you can design experiments better now, so that, or more clever, so that you get maybe a different data set out of that. You make different observations and you realize, well, no, it's sort of right, but not exactly. And so I would assume that that is also not confirmatory, but that's also going forward.
Yeah, and I just to add on to
Yes.
what Harold's saying, editors are people, right? And you can talk to them, right? And so if you, I mean, they're essentially other faculty members at other universities. You see them at a meeting, or you send them an email,
Right.
you know, and to go ahead, there's absolutely nothing wrong with that, right? To get there, because again, it can be discipline specific. There are certainly discipline specific issues.
Absolutely.
But also to add on to what Harold said, and you know, now we can generate these massive data sets, ask the same question, but be able to look at a much finer scale. So. But don't hesitate and don't think, well, I'm only a grad student, I can't talk to them. That is totally untrue. All of these editors, they run labs, they have students, you know, and they know that students are oftentimes the primary author of the publications they receive. So don't hesitate. You can look in the masthead of the journal you're interested in publishing, right? The masthead's just that first page. You can list the editor-in-chief, all the editors, the editorial board. Especially if you see, if you have a go-by paper and you go, how did you guys manage to do this? Talk to that author. I think that kind of guidance can be extraordinarily helpful and help you to build your network as well. So
one of the beautiful things when you start your career as a student is you don't just go to the lab, but you go to meetings. sooner or later you go to a scientific meeting. That's where you rub shoulders with people that you don't normally rub shoulders with, and then you can ask them. I mean, what do you think? And you gain a lot more confidence in your work, even when it tends to be perhaps a little bit confirmatory, because that's important. Find out what people think. You usually get a lot of positive feedback. So you can call, you can email, but you can also go to meetings, of course, and interact like we used to.
Right.
One-on-one.
And the likelihood, especially if you see somebody on an editorial board, they might get your manuscript to review.
Yeah.
Right. And it's okay to have talked to them about it before,
Right.
even. That doesn't sort of make them dirty in some way that they couldn't review your manuscript. So, good question.
I see a hand here. I'll come over here. Oh, yeah.
Thank you very much for the various insights you've given us.
Is it on?
Yes.
Okay.
I want to go back to the issue of plagiarism.
Plagiarism.
Yes. You mentioned that there are ways you can check like sequences of 2-3 words.
Yeah.
And I'm like thinking, if you are checking 2-3 words, definitely
We
you are
we don't check 2 or 3
2
words.
Okay. So I'm probably wondering, is there like a level of plagiarism that is acceptable when you like submit your manuscript?
Yes, a certain amount of plagiarism is acceptable, but don't run the risk of finding out how close you can get. And so I just wanted to warn you that it's a cyber tool, and so you can set the window any way you want. It's all just cyber junk. So you can say, you can set the window for 1, and of course then it's 100% plagiarized. Set the window to 2, and it's 98% plagiarized. Set the window to 3, and then it drops to 60% plagiarized. But we set the window at probably 6 or something like this. And so you pick up, basically at 6, you don't just pick up 6, you pick up about 12 to 15. You set the window at 6, and then you get the sentences. So it's very interesting if you're a mathematician. If you set the window too small, you don't actually get the sentences. But you don't have to set the window huge to get a sentence. You can set the window at 6 or 7, and then you get 20 words. That's plagiarism. And so we try to be forgiving because we're all trying to move forward. And just a little bit is okay. We say, okay. But when it's sentence after sentence or a block of paragraph, and then it's rejected. You're out. And if you're lucky, you'll be allowed to resubmit. I'll have to go over here.
Wait.
Or was there another one? Yeah. Why don't you help? Why don't you control this, Eric? This would help me.
Thank you. So let's say your manuscript is in the modification stage.
Yes.
And I feel sometimes reviewers are asking too much, which can basically generate another manuscript. I want to ask, as an editor, how do you control these kind of things?
So sometimes the reviewers are very enthusiastic. For the lack of a better word. They're very enthusiastic, and they want to let you know that they know a lot. And they know that you could do the next several experiments, not that you don't know this yourself. And the question then is the package of information that you want to publish adequate without more? And of course, the editor has to make that call. But usually the reviewers who ask for more are doing it because in the absence of this information, your conclusion is not correct. You haven't really proven what you're saying. So an unstamped so you have forgotten a critical control. You have not properly analyzed the data set, because underneath this is where the real answer is. And the superficial analysis does not allow you to make that conclusion. And so they call for more work. Those types of recommendations by the reviewers are important, and the editor will respect those. If, however, they're not like that, and the reviewer just wants you to do more work, then the editor has to protect you. But that's, again, the luck of the draw. But it is a problem. But in this case, so the way out is it's very clever. It's simple. So what you say is that, yes, we agree. This is what we need to do next. But this is not the focus of this study, and it's not necessary for the conclusion we're reaching and this kind of stuff. And then put that back into the hands of the editor. And usually the editor will go along with that, unless the work is needed to support the conclusions. Okay?
So do you see parts of the publication industry that are actually like currently in the throes of like dying or phasing out? So things like one of the comments you made before about getting your stuff seen and going into like a big journal that has like an enormous impact factor. We have the internet now, so you can find anything that you want. You don't have to only go into a certain stack of journals. So are there other things that you see like with the current culture that are kind of fading out that we might not actually have to take into account?
Maybe not. But it certainly is not a disadvantage. So if you're interested in longevity in the field of play, then certainly you cannot disregard certain journals. So if you're working in a certain discipline, there are certain journals that you don't have to, you don't have to embrace all of them, but there's some that you just can't ignore. And so you have to be a little careful. So there is a trend, for example, this preprint trend, to where you are going to submit a manuscript, but you publish it first anyway as a preprint. What do they call these things? Archives or something? Anyway, a preprint. Do you know what I'm talking about? Yeah. So, and preprints, they get a DOI or something like this, and you can cite them. They've never been reviewed. Well, why do I want to publish it again in a journal and get painful rejections? Why do I want to do that? My work is in cyberspace. People can see it. Move on. Why not? And so is there a danger in the peer review process, the industry that we've grown up with for over 100 years? I don't know if there's a danger, but certainly there is a new trend. And I would say that it's not journal specific. It has to do with the fact that maybe we don't need peer review anymore. Maybe we don't need peer review anymore. This will only happen when granting agencies accept unreviewed publications as credible. And when that day comes, I think science is in trouble. So are we in a danger zone? Maybe philosophically a little bit. But peer review is designed to help all of you with your work. By the way, we want to publish your work. Every journal wants to publish your science. We need your observations in the literature. But we want to make sure that when we publish this, that we work together as a scientific community, making sure those pearls are polished as much as possible. The review process helps you with the final polishing, and that final publication, when it does come out after review, is always a better manuscript. Maybe the conclusions are more or less the same, but the science is better. It is better. So the peer review process is not really a negative thing. It's a positive thing. And if we disregard this and we throw this away and we go to this preprint philosophy, then I think science is in danger. Science is in danger.
As a PI, I can say most of my published manuscripts have gotten better after the peer review process. Would you agree, Lisa? And there have been things that we haven't seen that the reviewers have seen.
Yeah,
and
absolutely.
And it became a stronger, better publication, as annoying as it might be.
Yes.
So it's better.
Yeah.
So I have a question on the resubmission.
Yes.
If I am rejected by a journal and I got the feedback and do some supplementary work and rewrite the manuscript, can I claim that, and I want to submit to the same journal?
Yes.
Can I claim that that's the first time I submit this manuscript?
No.
No.
This is a resubmission. It will be rejected. So if you submit without declaring it as it's rejected. There's no discussion. I don't even ask you why you did it. It's just rejected. We don't waste our time. You can come back and say, oops, I forgot. Then we will talk. It's very a serious error to resubmit the same manuscript to the same journal and not declare it as a resubmission. That's an ethical violation. And so don't do that. It's very simple. If you have submitted that story before, and even if it has changed 60%, but you have 30 to 40% of the data still in it, and basically 50% of the text probably, because you've already written it once, it's a resubmission, and you must declare it. Okay? And it's a simple error to avoid.
As far as rejection rates,
Yeah.
you said 70 to 80% of manuscripts get rejected.
Yeah.
What proportion of that do you? I mean, you talked a lot about ethical violations. About what proportion of rejected manuscripts are for ethical violations?
I don't have the exact number, but I'm going to peg it at a good 10%. I mean, there are lots of reasons. I mean, there are lots of potential pitfalls, not just one. And because of that, the likelihood of it happening is not zero. Well, 10% is low. If you're a mathematician, oh, that's not important. But if you're one of the 10%, it's important. So it's actually, it depends on the journal perhaps, but it's serious enough to where we're dealing with it all the time. As the chief editor, I deal with this all the time. I've got a couple of cases right now. I've been in the States for just a few days. I got a couple of cases I'm dealing with. So it happens. It's part of the business. And we're trying to do things with AEM, and this is published by the American Society of Microbiology. We're trying to do things to educate people. People just don't understand that these are pitfalls. This plagiarism stuff is a diverse range of things there that can go wrong, and people don't know it. And in some cases, it's a culture-based problem, that they just aren't raised this way. They don't think this way. But it's a significant problem in the publication industry.
Can you talk a little bit more about cover letter? Cover letter.
Yeah.
Because I just found like I want to know the fundamental elements in the cover letter. Sometimes I just found my cover letter is like some nice words and with my abstract again.
So there are different journal instructions to authors. Instructions to authors. For me as an author, I think a cover letter is fairly boring. My manuscript, please look at my manuscript. And the manuscript has an abstract. I mean, anybody can look at the abstract and the title to see, well, what's this all about? And so for me, submitting to a journal, I actually look at the instructions to author and see what do they want in the cover letter. And there are instructions. Some journals, they want you to declare that there's no conflict of interest. They want you to swear that all authors agree to submission and all this kind of stuff in the cover letter, but they don't want to know anything about the paper. Other journals, they want you to provide a paragraph of, well, why is this cool? Why should I care? I'm the editor. Convince me to send it out to reviewers. And so every instructions to authors, they matter. And so if the instructions to author encourage you to put in a paragraph of well, why is it cool? Put it in. And if it doesn't, it's not important. So instructions to authors. Okay. Is that okay?
Yeah.
So I have a question about the discussion. So the two things you said were like start out with a historical perspective and then don't say this is the first time. So those are the two things that I've been told to make sure you always put in the discussion. And it's like now I'm afraid to try to write another manuscript. 'Cause how am I supposed to do that?
Fear and failure are wonderful teachers. So, so it's a philosophy, but with first-time claims, what I can tell you is that some people think it's cool, but not everybody. And once you, as an author, have negative feedback from reviewers about blowing your own whistle too loudly, then you realize that, maybe that wasn't needed. And in the end, there is the danger of being wrong. And my philosophy, and things change. So I have in my career, a long time ago, done this traditional thing. I claim to be the first to have seen this. A lot of these claims are relatively trivial because we push the ball of science forward at the nanometer scale. It's very difficult to push the ball very far. So with a paper, you're basically pushing in a nanometer. It's really a small first-time thing. It's important, of course, but there's no reason to make it. So don't over-dramatize the importance of your work by these first-time claims. And AEM has many journals now. They instruct authors in the instructions to authors says, don't claim to be the first. So it's not just me as a person, but part at least of the publishing industry and the reviewers and the authors view science this way. Now, write a review article. Write a review. Then you can go into the history of the observations. And the first time that this was seen was this and that. You can put your own work in perspective. But in the primary literature, the reason we call it primary literature is because every publication is a first-timer. And so it's not really necessary. So I'll get off that bandwagon. And you can say first time if you want. That's fine. You won't get cited more. Okay? At least I think so. More importantly with the discussion, I think, is that if you have, just imagine that the reader has read the abstract and read the introduction and read the results. I mean, they're really saturated with your observations. They need to be called back to somebody else maybe. And it's actually a gracious way to let people know that there are others out there in the field. And to somehow create a clever way, just a couple sentences, to where you cite other people, not yourself. And then, of course, the main purpose of the discussion is to put the results in context with the literature. So you're going to be citing a lot of people. But make sure when you, in my opinion at least, when you start the discussion, you don't have to repeat the results. You don't have to repeat the abstract. They know it already. They don't need it there. They need something else. So it's sort of philosophical, but I think that it is a professional way to get into your work in the discussion. Start with somebody else first.
Yeah, as a reviewer, if I don't see a lot of citations other than the ones you're on in the discussion, it's a red flag. Yeah. You didn't put your work into enough context. Another thing to keep in mind, two things. First of all, where editors find reviewers is the papers that are cited in the paper, right?
Right.
And reviewers love to read papers where they're cited.
Right.
So it's just a little bit of, I'm not suggesting gamesmanship here. You need to cite what's important. But if you're going through the discussion and it's a rehash of results and abstract,
right,
and all you see is the citations from the lab you're in,
right,
it's a big red flag to a reviewer.
Right.
Yeah.
It's not good. Yeah.
There was another question, I thought.
There was a hand someplace I saw.
Thank you. Actually, I have a couple questions, but
Sure.
they're related.
Let's go for them.
Two cases. I want to go back to plagiarism,
Yeah.
and I want to hear how you deal with two different cases.
Okay.
One where you find with one of those CrossCheck, a significant amount of redundancy with a student thesis.
Right.
Is one of them, and the other would be in the case.
Answer.
Okay, great. Yeah. And the other would be.
Let
in the
me
case
just tell you right now,
right.
that's not plagiarism. So for AEM, sometimes a dissertation is copyrighted, whatever, all this kind of stuff. Yeah. But that is not considered to be a primary peer review publication. And so that is absolutely okay to, if you will, then plagiarize your own dissertation, so to speak. Yeah. So that's okay.
Yeah, they are, there's a copyright on thesis, right? And they are published, but so self-plagiarism. It's one of the very few places where self-plagiarism is okay, because the dissertation is not considered, for the journal at least, to be a primary publication, a primary peer-reviewed publication. And so that's allowed. What is not allowed
is if your student, who is the primary author of your paper, let's say, takes a bunch of information from the dissertation of somebody else, that's a no-go. And we flag that as plagiarism. Okay, so that was a detour.
So
right.
Second question would be from the perspective of a faculty. You know, I spend this 2 weeks writing this beautiful introduction for this proposal. So that's not peer-reviewed publication, but it's out there on the internet. When you're going to do that cross-check, it's going to flag it as this is already existing out there. It's not peer-reviewed, so how do you deal with that as well?
So we consider that to be a problem. So these scanners, what they're basically looking at is cyberspace. And it doesn't matter where it's published. A journal, of course, okay. Books, okay. It has to be out there to find. But a lot of things are not in, a lot of scientific information, Wikipedia and this kind of stuff, that's all taken very seriously. That's plagiarism. You take information out of the internet from any source. If you can find it, these scanners can find it, and they will. And so these scanners give you the list of the sources of where the information has come from. 50% of it is not coming from the journals. It's coming from dictionaries, Wikipedias, encyclopedias, progress reports, meeting proceedings that were never really, just all kinds of weird places. But it's publicly available information. That's plagiarism. If it's publicly available and recycled, it's plagiarism. It's serious. So if you're, I mean, let's say you go to a meeting. Let's say you go to a meeting and you have a brilliant abstract, and you use this for your abstract for the poster or something, and it's someplace lost in cyberspace, and so that's not interesting. It's not a peer-reviewed publication. It's at a meeting. I mean, there are places where they draw the line. We draw the lines at certain places. That's okay. That's okay. And these places that are, well, that's okay, it's self-plagiarism on the okay side. Okay? Self-plagiarism that's on the wrong side is when you recycle your own text from your other papers. You take out 3 paragraphs because they're brilliant from the introduction, and you attempt to use them again. That's self-plagiarism and a no-go. So that's a good question. A very fine detail there that's very important to understand. Dictionaries, danger zone. Cyber dictionaries, danger zone. Cyber encyclopedias, danger zone. It's not just journals. It's publicly available information. All dangerous. And I'll make this statement because we have a very international community. If English is not your primary language, don't fall prey to the temptation to take those beautiful sentences from the literature and use them, because you just cannot formulate that sentence yourself. You will pay the price, and your professors will pay the price. So it's a burden, and I'm a card-carrying foreigner. I live in Germany, could not speak a word of German when I went there 30 years ago. Okay? So I can talk about it. Okay? So it's tough to not speak that native language. And in this case, it's English. If that's not your native tongue, we don't expect you to be brilliant writers. And AEM, as a representative, normal, big journal, we have a team of copy editors who will correct all of your terrible mistakes. You have to be able to sell the science. But if we can sell the science, we'll make sure that it looks beautiful when we publish it. That's what we do for you. That's the service of the journal. So don't worry if the grammar's a little wrong. But if you can't formulate the sentences well enough to be understood, that's not a problem of grammar. That's a problem of language usage. And there we can't help you. A lot of manuscripts get rejected editorially, not just because of plagiarism, but because we can't understand them. We can't help you. Well, for $150, usually if you're doing research, you have a fairly good budget. So for $150, you send it to a service, and they will polish up all those sentences that really can't be well understood. and so it's worth $150. Or if you have a professor who has native English speaking capabilities, then you can solve that problem also. But make sure that if English is not your native language, that you don't make the fatal mistake that most do, because this is where most of these problems come from. They come from individuals who can't do very well with the English language, and so they purposefully use brilliant sentences from the literature because it's the only thing they can do. It's just a fatal mistake, so don't do it.
Yes, my question may be beyond the scope of the editor, but say somebody plagiarizes and you reject the paper, and then you later on find that that paper is published somewhere else. What is your responsibility as an editor that has rejected the paper? Do you do anything about it?
Our responsibility, so every journal is a little bit different, but it's a very important question, and it has lots of little edges, so let me just expand it just a little bit. If your manuscript, let us start with the basics. So if your manuscript is rejected because of an ethical violation, you go onto a gray list with my journal. That's societal journal, not my journal, but AEM. And that's the way most journals operate. So if you make a mistake once, you go onto a gray list. Nothing happens. We know, but nobody else knows. You know, but nobody else knows. The students, the other authors, they know, but it's basically contained. But we know. All the editors know also, by the way, because that flag is on your name. So, but it's not really broadly distributed. If you make a second mistake, then probably there will be sanctions, meaning that you are barred from publication for 1 year in all ASM journals in this case. And there are about 15 journals published by the ASM. And you will be barred from reviewing for that journal. Journals, in this case, journals. And your name is on a blacklist that is within the society is observable. We know it's there because you're on the blacklist. So this is a problem that can have a negative impact on your career, publishing career. If it is a very, very serious mistake, and there are very serious mistakes, then the journal can't punish you purposely, but professionally is obligated to notify your university. And then the university can decide whether or not this is a transgression that we need to take action on. But the journals won't take really legal action. But we can make sure that, I guess the idea is that we're supposed to protect science. And so if somebody is really out there fraudulent, falsifying, I mean, it's just really wrong, not borderline, just totally, absolutely unacceptable. And there are, thankfully, very few of these. Then the university administration is notified. And then very serious repercussions can happen. People can get fired for violation of publication ethics if it's extremely serious. So take this serious in that sense. That in the end, most of these cases are really trivial. That's not interesting, really. It's just an accident. People were naive. And then we try to make sure we educate them. This is how to do this. Please send it back and we'll close our eyes. But sometimes people are, criminal. They're criminal. And if you're a criminal, then the authorities have to be notified. And if you're doing something that is so bad, then the university administration can be legally notified. And although the journals won't take any action, your employer might. And so plagiarism can have, big impact on your careers. That's why I started with it.
Are there any other questions?
Sort of. It sounds so negative. It's not. Just avoid it.
Good. Wait, I think.
Thank you, Professor. It's very helpful. Illuminating. Just to follow up on the point, many of us at land-grant institutions write reports for our supporting agencies and nonprofits. And there will be 150 pages of reports. But there'll be something really new. New knowledge in there. So could you synthesize that and then submit it to a journal?
Yes.
Because it is your work.
Absolutely.
Yeah.
So these reports to scientific agencies or to institutes and this is not considered peer review publications. These can form the basis of a publication, a review or something. And so here, of course, you can reuse text, you can recycle. And we, at least I could say, we allow that, and we need to allow this, because your report's not in the public domain. Not really. It's not really, I mean, how would you find it? But if it was in a journal, and I know somebody said that why do we need journals? We find it in cyberspace anyway. That's not totally true. You look to journals for information sometimes. And some things are really hidden in an obscure place. And it's easier to find it if it's in a place where you publish information. So in any case, scientific reports are no problem with republishing.
I may have missed this earlier if someone had talked about it. What are your thoughts on publishing non-statistically significant data?
Well, everybody would tell you that that's not good. So if it's not statistically, so this is then, it's an opinion. It's a question that requires, what's your opinion? The more solid the data, the better, right? So I'm very old-fashioned. Now, Eric's not going to like this, but I don't like statistics. If you need statistics, you got a bad data set. Yeah, now I know I shouldn't have said that. So so now here I have a bush. There could be a bird in that bush. Okay. I've said this for decades, Eric. Okay. I'm sorry. I'm going to say it again. I'm almost retired, so it doesn't matter. So here I have a bush. Now, what's the likelihood of there being a bird in that bush that I can't see? That's a statistical question. That's a terrible question. I just go to the bush, and I stick my hand in, I got the bird. N equals 1. I don't need statistics. It's black and white information. There was a bird in that bush. Is there a bird in that bush? I don't know, and I don't care. I'm interested in my bush, and I get the bird. I don't need statistics for that type of novel observation. So, now, is that bird in my hand interesting? It's the first bird in any bush. It's novel. So I think the more novel your observations are, maybe the less, maybe you might be lucky and get away with it not being provable statistically. And I think that a lot of historical observations in the literature have never been tested for statistical significance. Statistics is sort of a modern thing in a lot of the sciences. And certainly in microbiology, if you look back in the old literature, they weren't doing statistics. It was black and white information like I just described. And basically, it's all pretty solid stuff. So do we need statistics? Obviously, yes. But in some cases, maybe not. And it's a question of whether or not you can get away with publishing that type of information. And it would depend on, I think, the information, the data set that you're trying to publish, and how you're trying to publish it. You're better off with it.
And one thing I wanted to add, because nobody's really touched on rejection, resubmission somewhere else.
Yeah.
Right?
Yeah.
And one thing that I've always advised folks in my lab when this has happened is act on all of those reviewer comments, because you got reviewer comments. Well, if it was rejected after peer review.
Right.
Editorial rejection gets no peer review. But if it got rejected after peer review, you have comments. If you don't act on those comments and you just like, well, I'll just go to the next journal with this manuscript, you risk having that same manuscript sent to the same peer reviewer. This has happened to me.
Absolutely.
I'm like, wait,
I
just wrote a review on this for another journal, and I got the same paper.
Right.
Man, I wrote that sentence in my rejection of the paper.
Yeah, because they didn't do anything.
Because they didn't do anything. And so the value of this system of peer review is that you get 3, hopefully, independent people who come back with a honest, objective evaluation. And if you don't act on those, you're really wasting their time, number one, and you're wasting a great opportunity to improve your work. So it was something nobody touched on in a question. I just wanted to make sure that got out there.
Yeah.
Okay, we got.
So if you go through that process, do you have to, in the second submission to a new place, disclose that you?
No.
Okay.
No. No.
Yeah, if if it's a different journal.
Why would you?
Yeah, yeah.
This was rejected a day ago. Do you want it? So even if that you just have the idea, you're in a danger zone there. Get away from that. No, don't. But take those reviewer comments very seriously. I mean, they're helpful. They're very helpful. I mean, some of them maybe are questionable and not really needed or overly constructive, but in general, most are. And it's to your advantage to change the storyline a bit.
Are there any other questions for Harold? Yes.
So, like, everyone wants to be published in like Nature or something that's sort of broad-reaching and everything. So how often does someone submit a paper to a broader journal and have it then sort of like slotted down through the ranks towards the more like specific arms of that
So I don't know
publication?
the percentage. I don't have access to that information. You might be able to, who knows, cyberspace gives you a lot of information. But in general, the modern trend is to try to shoot for the stars and see what happens. And so if you want to submit to Nature or Science just because you can say, oh, I submitted, probably never get to publish there, but I can say, oh, I submitted it there. That's a joke. So if you want to publish in Nature or Science, as an example of these top-end, these high-impact magazines, they are basically a magazine almost, but they're very popular. And if you want to be seen there, then what's the likelihood of being rejected? Like it's a jillion% or something. I don't know exactly the percentage, but it's a jillion%. And of course, those rejects, most of them, they're never reviewed anyway. And of course, do they go someplace else? Of course. So I don't know how many manuscripts that don't get submitted there initially are first submitted someplace else, but the number's much higher. It's much, much higher. Because there's not that many people out there that think that, oh, let's try to publish everything in Science and Nation, just see what happens. Most people don't want to deal with that because they need to move on with their life and with their work. And so they try to publish it in a more reasonable place, basically. So the answer, I think that it's a very small percentage of papers that are published in all these other journals that were first rejected by Nature or Science. I'll bet it's, I'm just going to say it's less than 1%, but I have no clue. I'm almost certain it's less than 1%.
And
can anybody challenge that?
Ironically, the Nature and Sciences of the world also have the biggest problems with plagiarism and with ethics violations, the most notable ones. So the higher the stakes, people roll the dice even worse.
Right. Yeah. And in those cases, then you get national news.
Yeah, exactly.
And we keep this under the table. We don't want to hurt anybody. We just have to try. Well, why do we care? Why do we care if you plagiarize? Why do we care? Why would we care if you plagiarize? Why would we care? Because the information that you're plagiarizing is copyrighted. And if one journal who holds the copyright, or if the author holds the copyright on that information, which includes text, if you publish something that's dramatically plagiarized, you can get sued. You are stealing intellectual property. And the ultimate fate of that is a lawsuit. Well worth avoiding. We keep all this under the table. But the nastiness that's extreme can be extreme, really extreme. So just avoid, it's very simple to avoid it, don't do it, and then it won't happen.
If there's no more questions, I think we can thank Harold again.
Well, thank you. It was wonderful to be here. Thank you. Thank you. Thank you.